So now that we know what is a function and if something is a function or not, we can say whether or not it's a linear function. So a linear function basically means it's a straight line. It is a straight line. Okay? So there's going to be lots of ways for us to be able to tell whether or not it's a straight line. Okay? Now, let me go through some of these fancy words for you here. Linear equation in two variables, so we've got an x and a y. We are going to use this form of an equation over and over and over and over. We're going to learn all kinds of things, but for right now, just know that if the equation looks like this, you would graph it as a straight line. Okay? Now, m and b, the m and the b, are constants. That's a fancy word for numbers. Numbers. Okay? The graph of a linear equation is a line. Like I said, linear function means you have a straight line. It has a constant rate of change. Constant rate of change. That means that it's going to go up or down the same amount every time. I forgot to point this out. It's a non-vertical line. So it's a straight line so it's linear as long as it's a straight line that doesn't go straight up and down. Can't do that. Okay? Now, a nonlinear function doesn't have a constant rate of change. So here's what I'm going to erase all my scribbles. Go back if you want my scribbles as part of your notes. Okay? But here's what I would like to see you write down. Y equals mx plus b, and then m and b are constants. You might want to use the word numbers instead of constants. It's a straight line, non-vertical, and has a constant rate of change. Those are the key points in this big old paragraph right there. So maybe write the whole thing, highlight those parts, or underline those parts like I did. They're your notes. It's up to you how you do it, but you need to make sure that this is part of your notes. This is huge. This is the very beginning of basically the rest of high school math. When we are looking at a graph, it's really, really easy to tell if it's straight line or not. Is this a straight line? Nope. So it's non-linear. Okay, is this a straight line? It sure is, and it's not straight up and down, so it is linear. Explain. This is part of your assignment too, where it says to explain. You would explain that it's curved or that it's a straight line. Something. You don't have to do it in a lot of words. Very simply is fine, but you need to explain how you came up with the fact that it's non-linear or linear. Remember that the word linear means a line. It's more difficult as we see different representations. So here we have a table. This is where it matters about that whole rate of change thing. So we need to think, do the x's go up or down by the same amount each time? Well, the x's are going up by adding 3 each time there. That is a constant rate of change for the x's. But the y's also have to have a constant rate of change. Not necessarily the same, doesn't have to be plus 3, but it has to be constant, meaning it has to be the same for each time you go, in this case, down. So we're going to go down by 6, down by 6, down by 6. So this is also a constant rate of change. Again, this doesn't have to be the same as this, but these all have to be the same, and these all have to be the same. So if they are, then this is linear. If, say, this middle one had gone up by 4, then it would be nonlinear. When we look at equations, so here's an equation, here's an equation, here's an equation, here's an equation. What we're looking for is, does it basically fit this? Which means the thing that you need to look for is our x single by itself, the same, without anything weird. So for example, here we don't even have an x, okay? So that's not linear. Here we have the square root of x. Well, there's no square root in this thing, is there? Nope, so that's not. This one, let me write that bigger, says y equals 3 to the x power. Well, that's just weird. We haven't seen anything like that yet, have we? And it's not this x being multiplied, so that is not. Now here, this says y equals 2 divided by x. Well, it's a fraction, and we don't like fractions, but that's not weird, right? That's not some crazy thing that we don't know how to deal with. And so we can say that is linear. I'm going to change my pen color maybe. So here we now have, I'm going to erase some of this stuff too. Now we have y equals 6 times x minus 1. Well, by golly, we know how to solve that. We know what to do. We know we need to distribute, right? And we end up with y equals 6x minus 6. Gosh, that looks exactly like this. So that one is linear. So this one wasn't, this one was. Notice on this last one, we've got x squared. Well, there's no squared going on in the form we want, right? So that must not be linear. We're going to do another one of these examples because I know this is confusing. So again, you're looking for the ones that have just an x, all by itself happy, without exponents or square roots or anything like that, which would be this one and this one. This one has a square root, so no. This one has an exponent, so no. This one is an exponent, so no. So it's just the two. Please, please, please make sure you're asking questions in class.